ओके सो टुडे हम लोग आज बात करेंगे पाइथन के बारे में फर्स्टली द क्वेश्चन विल कम लाइक इज दिस पाइथन इज अ इंटरप्रेटेड लैंग्वेज और प्रेटेड लैंग्वेज और compiled language like the compiled language like the basic C and C++ languages are there that are the compiled language. So if I'm coming to that question is like basically Python is a not the people will say that it is the interpreted language, but it is not like that. It is many researcher believes that Python is not a interpreted language or it is a compiled language, but there is a always a skew between them. So if I take an example like we have I can show something like Python is not purely an interpreted language. It is uninterpreted language interpreted language, but there is what we say that there is some kind of overhead like the python compiler will not show the things that are in the process in the background. So the python code we say like I write a python code, okay, now I will compile that code. So this is my he.py and in the compile process if I write -m here, okay, so this is the hidden for the user. We generally we don't write the -m signature here. So if I do like that, there is some kind of a thing is created here. So that thing, if I go deep into it, it is not it is the bytecode. Okay. So Python basically not directly convert their language to the machine code. There is some intermediate between them, that is the bytecode that it is converted. So it is not purely an interpreted language. We called it as a interpreted language because it is hidden from the user, so you cannot see that. You will write like this python hey.py, okay. So if you write like this, you will nothing will be created here, or you will not able to see this because this is going in the background. So that is the case. Now so we have come to the answer that Python is not purely an interpreted language. The things are hidden inside the background. Okay. Now let us talk about something called the reference count in Python. Okay. So uh, okay, if I write a variable lst, suppose it has some value 1 2 3. Okay. Now, if I write another variable lst1, which is equal to lst, okay. Now, if I change the value of lst 0 equal to 21, okay. Now, if I will print the lst, so it will be the clear answer that it will be around 21, 2, and 3. And if I print the lst1, so what will be the answer? You can comment me on the comment section also. So what will be the answer here? Uh, okay. So if I okay, so we are getting this because Python, everything in Python is the object. Okay, and these variables are assigned in the heap section. Okay. There are two memories in Python. First memory is the stack memory, and the next one is the heap memory. Okay. Now, stack memory only contains stack memory contains about the variable names. variable names. Okay. And heap here have the original values. And also coming deep into it like that, the stack doesn't carry any kind of variable type. It also don't have any kind of also don't don't have any of kind of variable declaration. Okay, means it don't have any kind of type. What kind of type is there, whether it is int, float, or else extras, so it doesn't carry that. And the heap section is the one that contains the value, or and also with that it also contains the type of variable it is holding. So it will tell me about the what kind of variable I am holding. So if I considered like I am holding some int or float, then it will be telling me that it containing the value of int, it containing the value of float, like that. Okay. So so okay, so what will happen coming to this? So these two memories are there, and coming to this portion, why it is showing me like 21, 2 and 3. Okay. So what what is happening is there is that have a stack memory. Firstly, in the stack memory the list is created. Okay, that is the variable lst is created. Then lst1 is created in the stack. Okay, now coming to the heap. In the heap, the reference of the lst will, the first 1 2 3 will be created. Okay, 1 2 3 will be created, and LST is referring to the 1 2 3. LST is referring here to the 1 2 3, and LST1 is referring to LST. So it is also referring to 1 2 3. Okay. Now if I change anything in LST, it will directly affect me also in the LST1. Okay. So how can we resolve that? How can we resolve that? So what we can do is that we can create a copy. So there is a library that is called the copy. Okay, so it will create a copy. If I write here copy dot copy. Okay, so this will create a copy of lst here. Okay, now you can see that 21 is not updated in the lst1. Okay, because a copy is created here. Also, in coming to the copy section, there are also two kinds of copy, that is the shallow copy and deep copy. These are very important terms when we come to the interviews, like what is the shallow copy and what is the deep copy. So basically the shallow copy is the copy that we create uh, and when variables are assigning to it, but there is some loophole here in that shallow copy is that it doesn't uh, allocate the dynamic memory. Suppose I have created a memory and there is a variable that is pointing to another variable. Okay, and I created a shallow copy. Using shallow copy I have created, so the the next copy is also uh, addressing to that variable. So in this way we only able to create like you only able not able to create a exact replica copy of it when we are dealing with the dynamic allocation of memory here. So for that the deep copies come into the play. So in deep copy what happen is that we will create exact replica, and dynamic also taken care in this. Okay, so what I have to write, if I have to make the deep copy, I can simply write the deep here. Okay, Okay. So if there is a pointer here, then it will take care of that. Okay. So for that reasons, we will create a copy. Now, uh, one more thing I wanted to explain here is the okay. So it's system file that contains that tell me about the reference. So what happen is that in the Python, everything is deal in the reference. If there is a some memory whose reference is 0, then what Python garbage collector do is that it will delete that memory. So we we can check the reference of it, but it is not always we are able to check. So we can write here print system dot get reference count. Okay. So it will be telling me about the how many variables are referring to the LST. So if I come to this, LST is the variable. Okay. LST containing this value, and there is a one that is referring to it. So there is only one, and one is because we are printing that. Now you can see that the reference changes because LST1 is also referring to the LST. So if we delete LST1 here, okay, now you will try, you will getting only two references. And now also if I delete LST and I will try to print the reference of, so LST variable is not present here, I can try it. Okay, there is a two reference and there is one only, it is referring to itself, so it is one. So it no one is referring it right now. Okay, so that is that the Python does is to allocate and deallocates the variable. If no one is referring to it, so it will delete that memory. So in that way the Python works. Now we have created one variable LST and LST referring to it. We have changed it value and print that. Okay, now if I will try to okay, so that's all.